Good morning, everyone. I'm Ronish Singh, a student of class 11th B, Macro School Dwarka, and I'm here with a project I really recently made. It's a car that you can control by your hand gestures. So if you tilt your hand forward, the car moves forward. If you tilt your hand backwards, the car moves backwards, and so on. So before we get into the theoretical part about the explanation, the applications, and everything, let's first start with a simple demo of it. So like I said, if you move your hand forwards, the car goes forwards. If you tilt your hand backwards, the car moves backwards. If you tilt your hands towards the left, it moves towards the left. And if you move it to right, it moves towards the right side. That's it. Forward, forward, left, right, forward, backward. Yeah, that's it for the demo. Let's get into the whole explanations of all the IC boards, the principle, how it senses a tilt, and every single thing. This is going to be really interesting. Okay, so for the explanation, I'm going to break this down into two parts: the transmission and the reception, and the processing and the output. So let's first start with the transmission. So the origination of the signal, which is sensing the tilt and then sending it to the transmitter, starts and originates from over here. From this mini breadboard, this white thing that you see, can you see four tilt sensors on it? There's one, there's two, there's three, and there's four. The tilt actually originates from here. So how this works is there's a container, and the two terminals are inside the container, and there's a small metal ball inside. So as soon as you tilt, the metal ball goes down, it touches the terminals, and it closes the circuits. So that's how the tilt is produced. And as soon as the terminals are touched and the circuit is closed, the signal goes down over here onto this amazing transmitter. And if you see this small red chip over here, it produces a specific frequency of 144 kHz to transmit the signal over to this car. Now, inside the car, there are 5 different IC boards which receive the signal, they process the signal, then they program the Arduino board, and then they finally give the output onto the motors, onto the motor driver shield actually, and then the motor driver produces a current that's enough to drive all the 4 motors, all the 4 64 kHz motors. Now, again, there's this green board and this red chip that again produce the exact same frequency of 144 kHz to be able to receive the signal from the transmitter onto the receiver. After receiving the signal actually goes onto this amazing and beautiful Arduino board. Now, you are probably able to see 2 layers of this amazing IC. Now, that's because I actually have connected this in such a way, so you might not be able to see the Arduino board, but the signal goes onto the Arduino board, and I programmed it in such a way that as soon as it receives a specific signal, for example, it reaches forward, then it orders the motor shield, the motor driver, to drive all the motors in one direction so that it can go in one direction, which is forward. So yeah, the signal goes onto the motor driver, and then now, yeah, a question that arises here is, why are there 2 different boards to drive the motors? Why can't you just give the signal directly from Arduino onto the motors? Now, this is because the current required to drive 4 motors of 64 kHz is around 5 times greater than the current that is required to simply power the microcontroller. This is why we need separate boards and separate ICs, which are commonly called motor drivers, to drive the motors. So yeah, the signal is gone onto the motor driver, and the motor driver unfortunately produces enough current to drive all these 4 motors. Now, yeah, of course it depends which direction you're giving in. For example, the direction I gave is forward. So then the motor driver is going to drive all the motors in one specific direction forward, which is a simple task. And same with backwards. But if you give the signal as left or right, how this works is actually both set of wheels move in opposite directions. So the left wheels move in the forward direction and the right wheels move in the backward direction, which is how it turns right. Now, unfortunately, because of this, the torque is greater and even the friction is greater. So sometimes the current required is huge, and it can lead to some breakage or some wheels not functioning, which is again why I've put these 2 batteries to produce more than enough current. And yeah, this is it for the explanation. This is how all these wheels work. Now, of course, coming to the applications, now no project ends without describing the amazing applications of the project. So gesture control, what could possibly be the applications? Well, the application of this amazing thing ranges from controlling a simple 8 kg motor to automating a whole mansion. And it's not limited to just that, but it involves the health sector, the educational sector, the consumer electronics sector, and what more. So yeah, for example, let's take an example of the entertainment sector. Gaming consoles such as PlayStation 5 or Xbox 360 or even the Wii remote, they use such an advanced technology of gesture control to make their games amazing. They use accelerometers, or what are commonly known as gyroscopes, to sense the tilt or to sense analog values of the motion and to make their gaming really enjoyable. Now let's take an example of the educational sector. Teachers use devices such as pointers to point on their screen, to use visualization as a learning factor. And of course, as pretty much every teacher knows, visualization is a really great way to make learning much efficient. And we can also take an example of the health sector. In hospitals, to drive operations such as eye operations, which need really high precision, which need millimeter precisions, robotic arms are used with gesture control to make such operations really easy, and no difficulty is observed when you're using robotic arms with gesture control. And yeah, if I keep on covering the application, that's probably gonna get to night. So yeah, this is gonna be it. Thanks for watching.